to cover, but welcome everyone to another installment of NEBRA's Lunch and Learn webinar series. And here at NEBRA, we're becoming more and more sophisticated, as I hope you'll see. So welcome to our Zoom webinar. Everyone should be muted for the session, and I ask you to remain on mute until the end of the presentation, and then we will open it up and I will invite you to turn on your cameras and your microphones and ask Chris questions directly. There's also a Q&A function there. If you'd like to type in your questions as they come up, I'll be keeping an eye on that. So will Chris. The session is being recorded, and the link to the recording as well as the slide deck will be sent to everyone who's registered after today. So thanks again for joining us to learn about some commercial biosolids gasification operations. Just want to mention today is my 2-year anniversary working with NEBRA. And I just want to say that what I've found to be the best thing about this organization is our members. You all do such challenging and interesting work, and you're always willing to share what you know to benefit NEBRA members and the profession as a whole. And Ecoremedy and today Chris Holcomb, those are the kinds of members I'm talking about. We're going to learn more about gasification for biosolids from Chris Holcomb, who is in charge of technical sales and business development. He's led the deployment of biosolids gasification projects for Ecoremedy since 2018. He originated the Morrisville project, which you're going to hear about, and the Edmonds project. You'll hear more about that. And Chris has quite an interesting career. After completing an MS in Environmental Sciences and Policy, he spent a season working in a heavy equipment shop in Antarctica. And then prior to joining Ecoremedy, he spent 7 years conducting regulatory compliance wildlife surveys during the siting and construction of utility scale facilities, renewable energy facilities in the Mojave Desert. So very interesting background, and I'm very pleased to turn this over to Chris. If you'd like to, I'll stop sharing and you can boot up your presentation for all of us.
All right, let's see here. All right, hopefully everybody can see my slides.
And I'm gonna go off camera and off mute, and just, Chris, if you could just be closer to your computer, we'll hear you better there.
Okay.
All yours.
And, right, I'm just making sure I can see the questions as they come in. Here. There we go. That's good. All right. Well, thanks, Janine, and thanks to all of you for joining today. There we go. Let's try this again. It's moving everything around. Give me just a second.
Looks good now, Chris.
It took my Zoom windows and put them over my slides. There we go. All right, much better. Thanks to all of you for joining today. And I'm Chris Holcomb. I run project development and business development for Ecoremedy. And we'll jump right in here. Give you some background on fluid lift gasification. Today we're really going to focus more on projects than engineering. We'll briefly go into what is gasification and some process overview. We can afterwards, if you'd like, we can schedule things like virtual tours and engineering reviews and things like that. But we'll go through that fairly quickly and jump into projects. So there's 3 that I want to talk about today. On the East Coast, we have the Morrisville Biosolids Gasification Project. That's a boom project in Pennsylvania at the Municipal Wastewater Treatment Plant. We'll get into some of the pilot performance. We've been operating commercially for several months now. Of course, everyone wants to know about PFAS. We'll talk a little bit about that. Then we'll move to the West Coast, where we have the Edmonds incinerator replacement project just north of Seattle. And that was a process sale through an energy services performance contract to a national ESCO company. So it's a little bit different. This is the city's asset as opposed to Ecoremedy's asset. That equipment has shipped and has been fabricated for installation later this summer. And we'll dig into biosolids, biochar applications a little bit more there. People are often very interested in what's going on with biochar. And then we'll go from the West Coast to the other side of the planet to the Roundwood project, which we recently commissioned in Australia. And so that is a wood waste project, but we're doing some pretty cool stuff with biochar down there. With wood biochar, it's going to inform what we do with biochar on our biosolids projects. So we will spend a little bit of time on that one. Yeah, absolutely ask questions in that as we go. And in a lot of cases, I might think, okay, I've got a perfect slide to answer that question. I'll wait for the, the process flow slide or a certain picture. So hopefully we can do those as they come in. There will also be time at the end. Can everybody see my cursor?
Yes.
Okay, great. So I'll be using that as a pointer. So big picture, what is gasification? Pyrolysis is an oxygen-free environment, and incineration is an oxygen-rich environment. Gasification is an oxygen-starved process with respect to the stoichiometric line, and the goal is to create syngas. In our case, that's mostly CO and H2. And the goal is really to create that gas. And for us, we're doing close coupled gasification. So we make syngas in the gasifier, and moments later, it's combusted in the oxidizer. So it's very different from some of the technologies you may have seen where the goal is to upgrade the syngas, maybe separate the H2, maybe renewable natural gas. We're close coupled gasification. And we really focus on thermal renewable energy from the combustion of that syngas. It's a little bit difficult to describe our gasifier. Really the best thing is the animation that we have on our website, which you can find here. And we've noticed the animations, when we try and play videos over this, it's so laggy and kind of blocky. It doesn't display well, but you can take a look here. What I will tell you is that it's a fluid lift gasifier, so it's a proprietary system. We tried fluid bed gasifiers, downdraft, and all the gasifiers that were on the market for wood and coal, and we found that they really struggled a lot of the time with high ash, high moisture feedstocks. So we developed the fluid lift gasifier specifically for things like manures and human waste. It has a moving chain grate, and so it spends 60 to 90 minutes slowly working its way through the gasifier, with under fire air trickling up through the bottom and generating syngas. It's a very quiescent process, so compared to like, again, fluid bed systems where you have this violent boiling sand, lots of air being pushed up through the bottom. Ours is incredibly quiescent, it's very slow, it's very calm, there's very little fly ash carryover. And it really looks like glowing barbecue coals with these kind of red swirling syngas vapors that are driven off to the oxidizer. So that's what I'll tell you about our gasifier. And I'm happy to take questions later. But yeah, that animation on our website really is the best resource. So this is our process train at the Morrisville project in Pennsylvania. And really what we've done here is we took a standard rotary drum biosolids drying facility, and then we married that with our proprietary gasifier and oxidizer, which are painted green here. These are fabricated in Pennsylvania near our operations headquarters. And so we married those two together with the gasifier supplying all of the energy for the drying process. And so when we do projects, our scope is everything you see here. So we take our gasifier and oxidizer, which are proprietary. We integrate all the other components, the air emission control, the drying, material handling, and then we have a proprietary PLC system that syncs those all together. So you can see here the gasifier, oxidizer, the rotary drum dryer. This is a single pass, goes to the cyclone, 3-stage wet scrubber, Here's our gasifier fuel feed bin. And then we have some material handling here. This is the dryer feed bin and feed conveyor coming up to the top of the dryer. The activated carbon filter, you can't see it in this picture, it's actually outside. And so this is what we've done in Morrisville. As you'll see in the section on operations, we've learned a lot during piloting. So we've made some adjustments to our standard process, which you'll see later. Before we jump into a more detailed process flow diagram, I want to go through just kind of the basic ins and outs of the process. So we take dewatered sludge coming off of a centrifuge or a press usually. That comes straight into our system. So you don't need wood chips or bulking agents or anything like that. And sometimes people get a little bit confused in terms of the end products because we have a dryer outlet, and that's where we have Class A biosolids that are produced. So that's one material handling stream. And then conventional to rotary drum drying, we back mix some or all of this, depending on the day, back to here to avoid the infamous sticky phase of trying to work with this stuff. So the dryer has its end product, and then the gasifier has a separate end product. So in the gasifier, 1400 to 1700 degrees Fahrenheit, the biosolids move through over the process of 60 to 90 minutes. And then there's a moving chain grate, and what falls out of that is ash or concentrated minerals. And so what we can do is actually tailor the carbon content of the ash. So it's not just like biochar mode or ash mode. It's really, we can adjust it in real time to tailor the carbon content of the ash. This is from poultry litter. We haven't been able to make biochar in Morrisville just yet because of sludge supply. But with poultry litter, we can get up to 40% carbon. It's very high ash content. With biosolids, we should be able to get up to about 60. But I kind of think of this, I grew up with wood stoves, so I think of biochar as kind of taking the glowing coals out of the fire before they can be reduced to ash. And then we have a lot of control over this process. So this is the more simplified ins and outs. And then we get to here. So a lot of the presentations that I do, we might spend 45 minutes going through this in detail with a really detailed process flow diagram and mass balance. For the purpose of this presentation, I just want to focus on a few things. One is the volume reduction. These are the percentages here. So this is a particular scenario where the goal is to operate to maximize Class A. So we might have 9% of the incoming volume leaving the system as Class A, 89% would leave the system as water vapor and exhaust gases, and 2% would leave as concentrated minerals. We use the phrase concentrated minerals instead of ash. When we work with utilities that operate incinerators, they definitely understand this because as far as the EPA is concerned, incinerators make ash. And so with gasification, we're moving away from incineration as a separate technology category. So as much as anything, it's kind of a rebranding of the concentrated minerals. And then at a technical level, in an incinerator, there's so much oxygen that the nutrients are glassed over. And our gasifier, the remaining nutrients are highly bioavailable. So on our manure and ag projects, we would actually land apply the concentrated minerals, and it was really effective. That's not typically done as much with biosolids, but that's where this terminology comes from. You can see the back mixing here. We have dewatered sludge coming in. Some of the dried product completely leaves the system. Some is back mixed. The rest that leaves the mixer comes into the dryer. We'll get into PFAS in a few slides, but you can see we've got this, spontaneous, highly exothermic reaction occurring here, 1400 to 1700 degrees Fahrenheit as we generate syngases. Those are channeled up to the oxidizer, where we inject air and we get spontaneous combustion at over 2000 degrees Fahrenheit. We have a fairly traditional emission train following. We always have options in almost every case, there will be enough energy in the biosolids for all evaporation. And then we're always looking for, what do we do with the rest of the energy? Because we're nearly always energy positive. That includes digestate. That probably includes THP, but I haven't seen a lot of good data yet on BTU per pound values for THP. And so we have a heat exchanger here. So in the process of dropping the temperature from the oxidizer to the dryer, we can use that excess energy for things like plume abatement and hydronic heating, preheating the under fire air into the gasifier, things like that. So again, I'm just going to move on here. We may answer some questions later and come back to this, but we'll just move on from here. So the first of the three projects is the Morrisville Regional Biosolids Project. This is in eastern Pennsylvania. Kind of for reference, the Delaware River is hidden in the trees back here, and the other side of the river is Trenton, New Jersey. Sometimes we're confused with Morristown, New Jersey. We're on the Pennsylvania side of the river. So we're in pilot operations at 2,000 to 5,000 wet tons a year. On the project development side, I use wet tons per year, and then once we get into actual operating schedules, days per week, scheduled downtime, we'll get into hourly and daily through rates. But for this whole presentation, I go with wet tons per year, and we standardize to 20% solids. The design capacity for this project is 25,000 wet tons a year. So we've basically been in pilot mode for the last several months. And I use the word pilot, even though this is a full-scale commercial facility, early operations, pilot operations, whatever you want to call it. So basically, while we waited to wrap up the permitting for full design capacity, we've been running in pilot mode. We did recently get our general waste permit from the state of Pennsylvania that allows us to fill up the capacity of the system. We're in the process of contracting with waste haulers for waste supply in the greater Philly and New York City area. And then we're actually permitted for 110,000 wet tons a year. So that would be basically 4 process trains, 4+ process trains. And so we'll be going into a third phase after we relocate this facility. It's a little bit confusing, but the city of Morrisville is actually going to build a new wastewater treatment plant. This project originated because the city had an aging wastewater treatment plant. It was going to cost as much to retrofit the existing one and get it up to compliance as it was to build a new one, and the city wanted to pilot technologies at that new plant. So within 18 to 24 months, this entire facility will be relocated to the new site. For now, during this phase, we've operated, this was a greenfield site. It was literally a patch of lawn, a stone's throw from the solids building. And this is a boom project. So this is Ecoremedy's asset operating on a tip fee basis and backed by Rockwell Venture Capital. Ecoremedy was acquired by Rockwell going on 4 years ago now. So we self-funded this project. I wanted to emphasize the footprint here. So this is 100 by 50 for the main process train. And so we can process an awful lot of tonnage in a relatively small footprint compared to some of the other technologies we're familiar with. And then we also do have a receiving building for trucked in sludge. But on most of our projects, we'll probably come off of a sludge pump from the solids building, and we won't need this here. So pilot operations out there. We've got some just kind of general statistics. So we've got 134 operating days as of May 14th, just a couple weeks ago when we ran these calculations. We tend to run about 1 wet ton an hour, 18 to 22% solids, 5 days a week, 8 hours a day. I'm going to jump down to here for a second because one of the surprises, these are the things that come up, they just don't show up in bench scale or lab scale R&D, is that the largest industrial source to the Morrisville plant is a sugar company, and they're often out of compliance. So that 5,000 tons that which we were expecting to be fairly steady, actually drops off to more like 2,000. So that means that we've been literally running until we run that metering bin dry. And so that imposes daily startup and daily shutdown. And as most of you know, facilities of this scale really aren't designed for that. So it's been an interesting challenge, and our operators are incredibly dialed at this point to handle daily startup and shutdown at this plant while we wait for the permit to haul in and bring it up to capacity. In terms of plant availability, we're at 95% on a daily basis for those 134 operating days. So we've operated the plant 95% of the days that we intended to, as opposed to unscheduled downtime. On an hourly basis, it's 72%. So those were days when maybe it's a Wednesday morning, you do a warm start, and 4 hours into the day, you run into an issue and have to shut down. So we're really happy with our plant availability, especially considering the challenges that we face. I think everybody had a tough 2020, and yeah, we certainly had some challenges as well. So again, the great thing is that in Morrisville, we're really testing this for all kinds of different deployments. And so it's good to get these kind of stress tests of the system to really learn how to handle whatever comes your way. So we've dealt with variable sludge volume, so that goes up and down, and quality. So our VP of engineering has done projects all over the world, drying projects. I think he's up to 30 biosolids drying projects. And he said some of the loads that have come to us are the stickiest material he has ever seen. So we can handle that. We can handle just about anything. So we have sludge volume and sludge quality challenges that we've had to meet. And then, yeah, the turndown capacity, instead of running it at 5,000 tons when it was designed for 25, we've learned how to run it at actually a 10-to-1 turndown ratio. We wouldn't do this on purpose, but we can certainly do it. The nice thing about having, the rotary drum dryer coupled with our gasifiers, it can handle within the same system really high turndown. And the great thing about that is, you know, we see in some of the projects we're developing, you know, college towns and resort towns, the variability within the year of, you know, the monthly biosolids production can be highly variable. And you looked at things like fluid bed gasifiers, and they don't really like going below 85% of capacity, so that they would really struggle with something like this. So we're especially pleased with the performance of our gasifier with
Hey,
this
Chris,
variation.
There's a couple questions here. I don't know if you want to answer these now, if the answers will be coming up, but average BTU value of incoming solids, is that something you know, or you'll be talking about later?
I will.
And how long does it take the system to get up and running? Shut down, start up, how much energy is wasted in that?
Right. So on the BTUs per pound, I'll actually have to get back to you since I was involved in the front end of the Morrisville development, and I've been involved in so many others since then. There's so many numbers in my head. I want to make sure I double check and get this one right.
Very good.
For the BTUs. In the morning, it's about 45 minutes of natural gas to preheat the system and get it running before it moves completely over to biosolids. And then, yeah, the shutdown can take a couple hours. Just depends on the day. But yeah, the goal is to move to 24-hour operations once we stop running the sludge bin dry, and then move to 5 days a week or 7 days a week. So yeah, it's just really nice having that turndown capacity as well, because as you'll see in the Edmonds project, the design capacity includes 25 years of population growth. But on year one, day one, really, you might only operate at 50%. So with some of these tricky installations, as you'll see in this incinerator room, it's great to have within the existing system a lot of turndown capacity. We also dealt with some variable power quality and supply. There was some rolling blackouts and brownouts. There's some power quality issues with the transformers near the plant. Again, this is the kind of stuff that doesn't come up in R&D typically, so we learned to manage that. A big one for us was learning to manage the relative humidity heading into the carbon filter, the activated carbon filter for polishing our exhaust. Running a drying plant, there's an awful lot of moisture coming off the system, and that can clog up your, foul the carbon. So some of this downtime here, we've been learning how to manage the relative humidity, and this is a thing that happens when you are doing daily startup. There's too much moisture coming in, it goes into the carbon filter, and the guys go home for the night and it freezes overnight. So you have a surprise waiting for you the next morning. So this was definitely a learning curve for us, and we finally got it. We passed multiple odor inspections in a residential area. So as many of you have probably encountered, we build a new biosolids facility, and neighbors assume that if they smell anything, it must be that new thing they read about in the newspaper, or the new thing that they can see now. They can see some moisture plume coming off of our system. But we're at a aging wastewater treatment plant. We're surrounded by landfills, all kinds of odor generators, and we've had half a dozen odor inspections, and we've actually been exonerated every time, and we run under negative pressure. We actually had a lot of compliments about our odor control system, but the neighbors are very close by, not quite a stone's throw away, but within a couple 100 feet of the treatment plant. So we've learned a lot on the odor control side. I'm going to pause just for a minute here. I can't see the questions as they come up. I don't know what happened there. No. Janine, you can just...
I can monitor them for you. I'm going to keep going, Chris.
Okay. We have had to upgrade some of the material handling. So we've had a few components, like mixers and conveyors, to say, yeah, this works, but it's not really what we want to use for the next 20 years. So a lot of the upgrades that we've made have been material handling. And one thing that we're really proud of is that we actually designed this facility to run. It's capable of running as a natural gas drying facility. We can actually completely cut out the gasifier, and that's part of how we manage the technology risk on our side with the scale up. And the gasifier has been so reliable, we've never needed to do that. So really, our CTO likes to say that gasification is a material handling problem with a fire in the middle. And it really is, material handling has been the greatest challenge. And that's where the upgrades have come in. So we're feeling really good as we design our new projects and start to increase capacity, that we're really on a good foundation to continue growing. So yep,
just a couple quick questions here, Chris. Yeah. Could you run continuously 24/7 if you had sufficient feedstock?
Oh yeah, yeah. Okay. And the permitting got bogged down during COVID. The state regulators admitted that the bureaucracy just really wasn't set up for working from home. So we expected this low sludge scenario to run for a few months, and then not a lot happened in 2020 on the permitting side. So we just had to run a lot longer than expected that way.
And then there was another question about the 8 hours a day operation instead of 24/7. You already answered the startup and how long that takes, but since the 8 hours operation, has it been consistent with no shutdowns? So you're doing 8 hours every day, basically.
Yep. That's always the goal. And then this is the plant availability on times when we get partway into the day, the carbon filter clogs, maybe something jams up. And this was mostly at the beginning. And yeah, we're getting better and better as we learn to manage those types of things. Of course, being a drying facility, the quality of the dried product is important. So we're also really proud that we've had some loads where it looks like Jell-O coming in, and we're still making quality Class A product. At this point, it's all being back mixed and taken down to concentrated minerals. Basically, when you're running at a 10-to-1 turn down, the thermodynamic efficiency is fairly low, and so we just have to squeeze every BTU that we can out of the solids, especially when the moisture content comes up. So there's no excess energy in the system to make anything but concentrated minerals at the moment. But that should change very soon. So of course, everybody wants to know about PFAS. So we did do a little bit of preliminary lab work. We took some of our concentrated minerals and sent them off to Eurofins. So we got non-detect for 36 different types of PFAS at the 2 parts per billion threshold. Using that, because I know I've seen Bioforce for their biochar uses 2 parts per billion. I've seen different labs have different non-detect levels. But we're feeling really good about that level, considering that we were quite a ways outside of design conditions. So it will only improve from here. So we were definitely happy to see that. And then we have a vapor phase PFAS company kind of ready to go once we have the capacity to actually invite them out and do these long test runs. And in the meantime, we've been watching the ChemOrs study. This is a PFAS factory, chemical factory in North Carolina. And they tested vapor phase PFAS destruction in a thermal oxidizer fueled by natural gas, followed by a packed bed scrubber. And so this was just last year, and they're finding consistent, really high PFAS destruction levels in vapor phase in that thermal oxidizer at about 1900 degrees. And so at over 2000 degrees, we're also feeling really good that in the gasifier, 60 to 90 minutes at 1400 to 1700 Fahrenheit, we'll be destroying most of the PFAS there. We're liking what we see in the concentrated minerals. Anything that volatilizes and goes up the stack, we should have really good efficiency of destroying it in the thermal oxidizer, which uses natural gas, or it uses syngas. And then in the future, we'll be using the pack scrubber as well. So there's a lot to learn still, but that's where we're at this point. I see a question here. The samples for PFAS, it was just our the ash bin, if that makes sense.
Couple quick questions, Chris. They're kind of related, but where did you sample for the PFAS? Were the concentrations coming in the dryer from the cake solid? What were the PFAS concentrations in the dryer coming from the cake solids? Did you sample that?
No, I only have data for what came out. I've seen, actually I'm trying to remember now, there was definitely presence of PFAS coming in. We don't have a good handle of exactly how much, but it's not like it was sterile coming in. And again, we didn't want to spend too much time on this far outside of design conditions. So we just kind of did one test, said, okay, it's a good start. And then we'll really focus more once we get into operations. And we have not tested the Class A yet.
Thanks, Chris.
Mm-hmm. In terms of project tours, we have done a few out in Morrisville the last couple of months. This is a quote from Emma Randolph. She's the treatment plant manager over in Edmonds. So I was impressed with the operation in general, the cleanliness, the controls, general ease of operation, and the operators. We've gotten a lot of compliments on the cleanliness. People say just about eat off the floor. It's not what we were expecting. And then also the fabrication shop in terms of attention to detail and quality control. The fact that Dave Mooney, who's our president and CTO, seemed to have a personal connection with the shop technicians, gave me comfort. He was overseeing the whole process. So yeah, our core components are fabricated a 5-minute walk from Dave's house, and he knows all the fabricators and stops by, and they do some spec fabrication for us. So it's great having them close by. They're local, and we've seen some challenges with getting a lot of wastewater equipment is manufactured in like Germany and Italy, and getting that stuff over the border during COVID was a real issue for a lot of people. So it's been great to have manufacturing done right in our backyard in Pennsylvania, and the rest of the components come from US manufacturers. So from there, we'll move on to the Edmonds project. So in Morrisville, that was a boom project. That's Ecoremedy's asset, operated on a tip fee basis. This one was a little bit different. This was a process sale, so everything you saw in that building to the wastewater utility in Edmonds, and that was developed as an energy services performance contract to a national ESCO company. I was checking the chat. It's another example of different ways that we can do these projects. The big issue in Edmonds, it's a very challenging and fun site to work with. So it's an incinerator replacement. It's in this building. The only other place to install anything would be this tiny parking lot. The entire treatment plant is enclosed. They have neighbors literally across the street in high-end apartments. The ferry terminal, to get on the ferry out to the San Juan Islands, it's right here, and the only access to the building is to basically cut a hole in the wall and shut down the ferry traffic. So on a construction and engineering side, it's a really challenging site. They spent quite a few years trying to find a technology provider that could replace the incinerator within these constraints. So that's a design capacity of 14,250 wet tons a year of pressed sludge. And then this will be the first project where we're co-gasifying all the grit and screenings. I can't remember what the tonnages are on those, but those go into the gasifier, not the dryer, as separate streams. It's a really neat project. It is fully engineered and fabricated. Most of our equipment has made it to the site. With Morrisville and Edmonds, all the components were it was under a year for fabrication and delivery. So we can move pretty quickly on these projects. This is our oxidizer and the oxidizer cone, gasifier components. I believe we went with the triple pass rotary drum on this one because of the space constraints. And then here's our bucket elevator on the truck headed out. So we're really excited about this project. It was slated to begin installation like next week. Obviously a lot of moving parts for a project like this with different construction schedules. They're now expecting to start demolition of everything you see here this fall. Yeah, we should be commissioning by early 2022. So this is a view of the upstairs in the incinerator room, the existing building. So actually I'll go over to here. Downstairs, we've got 56 by 39 length and width, and it's 37 feet tall. They call it the box. So it's vertically oriented. So in Morrisville, you saw a horizontally oriented system. And so we had to get pretty creative to move to a vertical configuration. And so we took our kind of standard process train like this and kind of folded it in half this way and this way. Have this novel configuration: the gasifier, oxidizer, heat exchanger, drying, cyclone, and then some odor control and material handling upstairs. So really neat project. So as we found in Morrisville, and they have found in Edmonds, so this is the plume coming off of our carbon filter in Morrisville. I think we've reduced the relative humidity quite a lot since this photo was taken. But the incinerator operators in Edmonds told us the more that people can see steam, the more odor complaints they get. It doesn't change the chemistry, but just visually, people think they smell, they get more odor complaints when there's a visible stack. So in Edmonds, we're playing with having enough energy. So basically you have an energy recovery and a biochar trade-off. I just want to emphasize, anytime you're making biochar, again, it's like if you're pulling fuel out of the system. So you can kind of go towards more energy recovery to preheat this stack, or you can go more towards biochar production. And there may be a balance point where it's not 60% carbon biochar coming out of the system, maybe it's at 40. But that'll be one thing that we're playing with, and there might be seasonal changes in demand for biochar. seasonal changes in the relative humidity right there on Puget Sound. Maybe it doesn't matter as much in July as January. But I just want to emphasize this because this is quite a bit of energy leaving the system, and sometimes you do get trade-offs. It was Dave Perry from Jacobs Engineering, a consulting engineer for the city on this one, and we did a nice presentation at WEFTEC last year. And then Ron Alexander, who many of you probably know, is working with the city on their biochar plan. You know, what are we going to do with this product? What are its applications and uses? I've only seen his draft report. I haven't seen the final. But that'll be really exciting to see what we can do. So this slide, all of this here is taken directly from the city's presentation. They've been doing energy efficiency upgrades for years, and the biggest one at the plant was the incinerator replacement, moving from fossil fueled incinerator to biosolids fueled drying and gasification. So they were selected in 2020 as a utility of the future at WEFTEC. So we're really proud that out of the 3 projects that we've been working on the last year or so, 2 out of the 3 have been award winners or finalists, and that includes this one. So this is directly from the city's slide deck at WEFTEC. And out of all the technologies they looked at, what they liked about us is that it was efficient, affordable to implement, the lowest cost to operate, no acidic side stream or hazardous waste byproducts. Really neat project. And then their slide does reference some of our past projects in the ag industry. We'll get into this in a minute, what we're doing in Australia. And there's a link here to the Treatment Plant Operator magazine article about Edmonds that came out last month. Doesn't spend as much time on the gasification side, but you can learn a little bit more about what they're doing out there. So I did want to take a minute. I've been working on the biochar side of talking with soil blenders and potential customers in Pennsylvania. And I wanted to share some of the things that I'm finding in some of the research that I've been looking through. So there's a great paper that I highly recommend. It's a review paper from the lab group at Marquette University. We have some Marquette alumni in the audience. It's called Characteristics and Applications of Biochars Derived from Wastewater Solids. So they reviewed dozens and dozens of papers from all over the world. It's kind of my Bible for this subject. It's lots and lots of information. And so it's one of the things that they point out here, which I found talking to soil blenders. For biosolids biochar, its best use is really for acidic and neutral pH soils, and soils with coarser medium textures that don't hold moisture well. And that's exactly what I hear from the soil blenders. It really depends on where you are and the pH of the soil. We've also heard from composters that when you blend in biochar into compost, it acts as a deodorizer, which is pretty amazing. So depending on the composting product, that can be incredibly helpful. And maybe the goal isn't pH or moisture retention. In contaminated soils, they're finding that the biochar can absorb endocrine disrupting compounds, pharmaceuticals, pesticides. And the way that we create biochar is to do it slowly at high moisture and steam it from the inside out. So we actually are getting an activation, just like with commercial activated carbon. It is steam reformed. So we have steam reforming going on inside of our gasifier. So we're really excited to start to play with some of these applications. I think the one that I'm most interested in is really filtration and aqueous solutions as kind of a powdered activated carbon substitute. So they're finding it can remove a wide range of heavy metals from aqueous solutions. This particular study, the absorption of cadmium was actually higher than activated carbon. They find that a lot of the charged ions in biochar, so it may have lower surface area than other biochars, but the presence of charged ions, the charges are so powerful that they kind of draw things in. And so they can be just as effective, if not more, than activated carbon despite a lower surface area. They're also finding good success at the lab scale with COD and color removal, of ammonium and phosphate absorption. So I'm hoping to see some studies soon where we play with things like stormwater, manure lagoons, maybe even leachate. And so we really think that in the future, biochar is going to be the way to go, and there'll be some really interesting uses for that product. I'm going to move on, and we'll only spend just a minute here on the roundwood project. We'll kind of go through this circle here. So we'll be taking in 16,000 tons of wood waste per year in South Australia, a few hours from Adelaide. So we have shipped wood waste coming in. We're going to convert it to biochar and steam. 100% of the steam for pressure treating the new wooden poles is supplied by Ecoremedy, and that steam is going to be condensed and filtered through biochar for reuse. So pressure treating poles, you have an autoclave. It's interesting engineering because we need consistent biochar production with batch steam demand. And that was an interesting one. And the goal of the project is really to actually use biochar as the filter to condense the steam, run it through biochar, and do basically industrial water reclamation. As you know, Australia is a very dry place. They've had a lot of fires, and so reusing water is pretty key down there. So you have the old poles coming in to create the energy source for the new poles that are going out to vineyards, utilities, farms. This is the largest pole manufacturer in South Australia. If you drink Australian wine, roundwood poles were probably involved. And then we're looking at what the balance is going to be for how much biochar we need for filtration versus going back to the soil. But they definitely can use the soil carbon and the water retention, so they don't use quite so much irrigation water out there. And then the waste poles come back. So we have a really neat example of a circular economy with this project. We're just starting to announce it now that it is commissioned. There's a challenge to commission remotely to the other side of the planet when flights were basically grounded. We commissioned it remotely, and we wrapped that up just recently. So they did win, they were a finalist for the South Australian Climate Leader Awards. And the judges especially liked the gasification component. And they're also moving away from toxic compounds like creosote towards environmentally friendly, non-toxic compounds in their wood. So they're a really neat company to work with. Just an example from some of the vineyards down there. And I just wanted to reinforce that, as a soil amendment, biochar has really specific applications, not just put it on any old farm field. And so you can see the strongly acidic and acidic surface pH on the map. So the facilities in Mount Gambier, so really in a pretty good zone here to actually utilize the biochar. Not everybody is, it's really project specific. We have some very dedicated employees at Ecoremedy. Our VP of Engineering and Operations, Brian Novak, recently got a new license plate, and he is committed to the core. So if you see the Biosolids license plate up there in New England, make sure you give him a hard time. And that's all I've got. We can do some questions.
That's a great license plate. I'm sure some of our members are coveting that. I was going to ask if you guys are comfortable. I'm just going to allow Mo to speak because he had a couple of questions that I don't think I'm interpreting correctly. So I'm going to put him on. Mo, do you want to turn on your camera and your microphone? Yeah, just because I know I'm misinterpreting your questions.
Hello?
Hello.
Hello.
Did you want to ask him your question?
Hello?
Hi.
Hello.
Hi, Mo. We can hear you. Yeah.
That's okay. I typed my question and
You think you're all set? All right. So another question, Chris, is can you speak a little more about the agricultural gasification projects in Missouri 2012 and Pennsylvania 2014? Are they still in operation?
I can't hear.
What's going on? Mo, you can't hear? Hang on.
It's not a Zoom call if there's not some audio difficulty.
I know. Can you hear now, Mo? Okay.
While he gets that sorted. So yeah, the project in Missouri, this was at a digester. Yeah, in 2012, they said we've got more manure than we know what to do with. They added a digester for all that dairy manure. I believe it's dairy. Dairy manure and cattle manure are actually quite a bit different. I believe it's dairy manure. And so they added the digesters. They still had more digesters than they needed to do with. I think this was around 17 wet tons a day. And so what we did was we actually ran a drying facility specifically for this. So some of the manure was reduced to ash. The rest went through the dryer. And so the dried product was used for an alternative peat moss substitute. It was bagged and sold. And then actually, so when I talked about concentrated minerals, the manure ash out of our system, we spent years really getting it right so that the nutrients were still bioavailable in the ash. So they would actually put it out in the soybean fields, and it worked great. So it allowed them to get a lot of the nutrient value out of the manure, but the ash was so much easier to store. There was no odors, no combustion risk, or storage issues. It was a really neat project, and that operated for the better part of a decade, and then the dairy just went out of business. Ag is a tough industry, and so that project is no longer operational. Yeah, it went for several years in Missouri. And in Pennsylvania, we have a project at a poultry facility. So they've got.
Could you just speak up a little bit, John? I mean, Chris, sorry.
No problem. Yeah, how's this? This better?
Thank you.
Okay. So in Pennsylvania, it's Lancaster County out in the Amish country. He's got 100,000 square feet of chicken houses, poultry houses. And so we took all the poultry litter and bedding, a mix of poultry litter and wood chips, and that went straight into the metering bin. The farmer basically loads the metering bin every morning, walks away. If his phone throws up an alert, goes and checks on it. But it was fully automated, and that was gasifier only, and it converted the poultry litter to hydronic heating. I think we were heating 100,000 square feet of poultry houses just with that hot water system. And then again, they would take the ash from that, the concentrated minerals, and again, it made a great fertilizer. And I'm certainly not an agronomist, but I understand that the form of phosphorus in that poultry litter ash doesn't tend to attach to soil particles and run off during storms. In Pennsylvania, it's where a lot of the Chesapeake Bay issues come in, nutrient pollution from the poultry farms in central Pennsylvania. So we made a great fertilizer project, and we covered a lot of energy. It really only runs in the winter when they need the heating for the farm. So it replaces propane gas. I forget how many months a year it runs, but it was a cool, for all these, we have more information on our website, and there's a great video done by an environmental group that we have featured on our website. Some drone footage, and you can see what they're doing out there.
And yeah, I'd be happy to share that when I send out the recording. Another quick question from Mo. He can hear again, thankfully. He's just curious, out of the 134 days you've been operating in Pennsylvania there, how many wet tons have been processed total?
Yeah, I don't know the
or dry tons, wet or dry, whatever.
Yeah, I don't know the answer to that. I'm more involved in the project development side, not the operation side, but I can get that number.
Very good. We'll include that when we follow up. Yeah, there were some other questions about, there was one question about, does the system treat any of the effluent water flows early on? I'm not sure, but you did mention about treating lagoons and leachates and stuff.
Yeah, we think those will be interesting applications for biochar. We do have flow down from the scrubbers that usually goes back to the headworks of the plant. We haven't had any issues with that. I think of what other.
But basically, you're co-located with a treatment facility, so any supernate or anything else is coming off is going back to the head of the plant.
Exactly.
Okay. All right. I think I've got all these, but I will get a report out, Chris, on questions. So if there's any that we didn't get to, I will follow up and we'll get Chris to answer, and we'll include it with the slide deck and the link to the recording.
Good. And I see from Jeanette Brown here the energy balance. And yeah, after this, let's talk for sure. We've done quite a few virtual tours. And yeah, we go through a lot of detail on the energy balance, the mass and energy balance, and we actually flew a drone through the Morrisville facility during operations, and then we got some videos of different points of the process. So between the heat and mass balance and the visuals, it's a really good way to understand what's going on in the system.
And I'd be happy to connect you with Jeanette, another one of our good members on our research committee, and I'll make that connection between the two of you. That'd be great. I think this is a research area for her. So, all right. If anyone else wants to quickly turn on your mic, turn off on your camera, and ask Chris any questions, we have a couple more minutes before we end.
Looking at this, looking at the difference between concentrated minerals and biochar, other gasifier presentations, and in biochar, what is different in your process between in different products? That's simply residence time and oxygen levels. It allows us to control the carbon content of the ash.
And the term concentrated minerals is just your term to differentiate it from like incinerator ash or other kinds of ash, right? All right, that's what I thought. That's what I told Tracy, but I'm glad you confirmed.
And the other big difference is we've seen some systems that incinerate manure, and they try and use the manure ash as fertilizer, but the nutrients are so glassed over, they're not bioavailable. So it's the distinction between ash and concentrated minerals is a little bit bigger deal in the ag sector where the ash is more used. I know in Germany they land apply incinerator ash and biosolids for phosphorus recovery, but just don't see that down here nearly as much.
All right. Well, thanks again, Chris. This was very interesting and very encouraging that we may have some alternative solutions here. And thanks to everyone else for joining us today on this precursor to the long weekend. We have other sessions lined up through October, so I encourage you to keep an eye on our calendar. And if there's something in particular you'd really like to hear about, just shoot me an email or give me a call. Let me know. I can find one of our members who'd be willing to share their knowledge on pretty much any topic. So thank you again. Happy Memorial Day weekend, everyone. See you soon, hopefully.
We see a few